Yo, what's up guys? Baby Bear 4812 coming at you one more time. Today, question number 200 on Leetcode. That problem is number of islands. As always, a popular one, almost 6,500 upvotes. Companies asking about it, Amazon, Bloomberg, Facebook, Microsoft, all the big guns. Super important problem. It's ranked as a medium. I think this one is manageable. It's very digestible, and I kind of hope that I can show you a relatively easy way of solving this one when you get it in your interviews. The approach that we'll be taking will be a recursive approach, and it will kind of be the optimal solution as well. So hang tight with it. By the end of it, if you don't get it, as always, let me know down below if you're confused kind of as we're going on. But I think this one will be manageable. It's kind of within a good domain. Now, with all that said, let's actually look at the problem. It says that we're given a 2D grid map of ones and zeros, where the ones are land and the zeros are water, okay? And within that grid, we need to count the number of islands. It says an island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically, okay? Not diagonally, just horizontally, vertically. You may assume all four edges of the grid are surrounded by water. Okay, so what do they mean by that? If we look at example number 1 here, this is our grid and the output is 1, meaning there's one island. The way we kind of define an island is by all the horizontally and vertically adjacent pieces of land, or ones, that we see. You'll see this row here, and then we kind of get this this foregrid here that attaches to it nicely, and then this one little it's surrounded by a bay, kind of one little tip of the island, and it's all one piece of land, so we would output 1. Conversely, and we'll dive into a deeper walkthrough of this example here in particular. You see we've got four kind of pieces of individual land all adjacent to each other, and this will count as one island. This one here, we've got a lone straddler, so notice that vertically and horizontally from this one, it's surrounded by water, so this would be an island in its own right. Notice that this one here and this one here that live diagonally does not count in this example as being adjacent land, so this is a separate isolated island. Finally, these two pieces down here are considered their own island, and so overall we've got, and again, 1, 2, and 3 pieces of land here. So I hope that's clear. And as I said, the one I kind of want to look at is this one right over here, the second example. And so what I've done is I've kind of drawn it out ahead of time, so we have a bit better of an example to work with. So as always, let's walk through and think about how we would rationally approach getting to a solution to something like this. Well, let's think about it. If I think kind of intuitively our first step is we set up some sort of nested for loops, where we'll walk through the array, or row wise and then column wise after. So let's say we take our first step onto here, and I inspect the first element of the array, and I step on this one piece of land, and I see a 1. Okay, so I think to myself, I definitely have one piece of land. The question now becomes, okay, if I take another step, maybe I see this one here, I go, okay, here's a second piece of land. The issue is that if I don't take into account the fact that this piece of land and this piece of land are adjacent, I would count them as 2 separate pieces of land, or maybe two separate islands. And that's not what we want to do. That's strictly what we'd like to avoid in this scenario. The reason we want to avoid it is because these two are actually adjacent to each other. Now, same thing, maybe we keep kind of walking along. So we notice, okay, these are adjacent. We keep walking along, bunch of zeros everywhere, kind of like high school all over again. And then we get to another set of 1s. We say, okay, same thing, a new piece of land. But if we take a look up here, we're like, well, this one's adjacent to this piece of land. This one's adjacent here. So in fact, these all kind of represent one big piece of land, or one island. So that's the issue with kind of just walking through it iteratively, one step at a time, is we don't know where one island begins and the other one ends. What we'd want to do then here is to take an approach of saying, okay, I've found one piece of land, so I've kind of stepped on this one here. Let me spread out, let me kind of expand and feel around all my surroundings to find all the other pieces of land that surround it. And then we can count all of those as one big island. And so maybe if I can make this a bit cleaner, maybe there's a nice way to kind of get a different color here. Maybe we'll go red. I get my artistic side out. So I step on this piece of land. I'm like, okay, cool. Well, adjacent cells means horizontally and vertically touching. So maybe what I want to do is I want to say, okay, let me check my sides and let me check my up, my right, my down, my left, and check all those and see if there's any other pieces of land. So I check to my right and I say, okay, cool, I found another piece of land. Now I'm kind of sitting here and I think, well, let me keep checking right, or rather even let me check up. Can't check up because we're at an edge, so that's no bueno. Can I check right? No land there, we're all good. Can I check down? Oh, okay, there's a piece of land, so maybe we got this one here as well. Now we jump into there and we ask ourselves again, let me check up. We've seen this one already. So we're gonna talk about how to deal with that in a second. What if we've already seen a piece of land? To the right, nothing. To the down, nothing. To the left, oh, cool, here we go. We found something. And same thing, kind of rinse and repeat. And you'll find that we've now found one piece of land, and we're gonna tally that one up by one. We keep traversing through here. We eventually stumble across here and we say, okay, well, I check up, right, left, down, nothing to be seen anywhere. This is one piece of land. And by similar logic, we get here, get one piece of land. Overall, we got 3 pieces of land. Now, the trick here is going to be how do we take into account what we've already seen and what we've already counted, so that when we get to, let me kind of undo this, get the scenario here, and I say, okay, well, what's stopping me from jumping back up here and then pointing back here and then going in a loop here and then kind of perpetually getting stuck in this motion of checking more and more pieces of land? The answer is there's 2 ways to do it. There's one way that I prefer and I like, and there's another way which I won't opt to go with, but I'll explain both methods for sake of completion. One method is to say, let me create a 2-dimensional array of size m by n, so kind of the same size grid that I've got here. And let me create something like that here. And what I'm going to do is I'm going to call this array scene. So I'll keep n squared memory, and I'll see, maybe I'll set all these to false at the beginning because I haven't seen any of them. It's going to be false all the way down and across. I think you guys get the picture. Once I step foot on one piece of land, I will then say, ooh, okay, I've seen this. I'm going to set this to true. I'm going to set this to true. And now as I'm kind of checking my boundaries, I'm only going to jump to pieces of land that are a land and that 2 have not been seen. Does that make sense? This approach, it's crystal clear. If you did this in an interview, it would be a good first step, and you'd be very much on the path to actually kind of getting that done and solving the problem. But we can do better. I do say that with the caveat that, as I always suggest with you guys, you need to clarify with your interviewer whether it is okay to modify the input that you are given. If the answer to that question is yes, you are allowed to modify the input. What you can do is something like this. And this is the kind of the method that I'll be describing here. I step on my first piece of land, I say, ooh, piece of land. Let me change that to hashtag, some arbitrary, pick your favorite symbol. My count goes up by 1. I see a piece of land, I'm going to bring my count up by 1 because no matter what, no matter how big this island is, if it's 1 piece or 100 pieces, I found 1 island, at least. I now check all my adjacent points. Ooh, I see another piece of land adjacent, awesome. Change that to hashtag. Another piece of land, ooh, awesome. And again, the way that we're defining a piece of land is by seeing a 1. So if I'm now sitting here and I ask myself, is there a piece of land up above me? There is not, because this up here is now a hashtag, it's not a 1. I'm modifying that input in such a way that when a piece of land was visited, I'm going to mark it with something that is not a 1, because our condition to finding a piece of land was something marked with a 1. I do the same thing here, and now I look around me, well, up, right, up, right, down, left, no piece of land anywhere, I'm done. My count is at 1 here. As we go through, I'm going to modify all my inputs that I step on, that are my scene. I'll modify those and kind of change them to a hashtag. And so that way I won't be double tapping or double stepping onto pieces of land multiple times. You'll have 1 here, 1 here, 1 here. 1 plus 1 plus 1 equals 3 last time I checked. And so that's what we're going to return. Everyone's happy. I hope that makes sense. And again, this is under the caveat that your interview is kind of all kosher with you modifying the input, which should be okay. Again, just ask the question first. So if that makes sense, I think we're just about ready to jump into the code and see how we can make this happen. So, as always, I like to begin with some error checking. So we'll say if we're not really given a proper grid or just an empty one, we're going to return 0. We may be able to get rid of this because our code, I think, will account for it anyways, but TBD. What we're going to want to do is we're going to set some sort of result variable, like a number of islands. I like to call it result because I'm super creative. And at the end of my program, I'm going to want to return that result no matter what. We said the first thing we're going to do is to start looping through this, kind of looping through item by item, row by row, column by column. And so in order to do that, we're going to set a nested for loop. So we'll have for I in the range and the length of the grid, and for j in the range of the length of the grid at that specific row. Now, what do we actually want to do here? When things start getting interesting is not if we see a 1, not if we see a 0, because if I step on a 0, it's like, okay, cool, water, next. So what we really need to be doing is to say if we step on a 1. So if, not grid, if grid of I, j is equal to a 1, then we're gonna do some cool stuff. Okay, that's the first piece of information to kind of understand. We only want to be jumping into this process if we see a 1. And again, when we change it to hashtags, we're no longer going to be seeing them, which is why we want to kind of modify them as we go. Now, first thing we want to do, and remember we kind of said this in the explanation, the second I see a fresh piece of land that I have not seen before, that means I've found one more island. Okay, one more island. That's not part of this traversal. So I'll find a new piece of land and then I'll traverse and I'll kind of mark up all the attached or the adjacent pieces of land. But this first one is fresh. It'll always be fresh, and that's the key thing to understand here. So this is where we're going to increase our result by 1 no matter what. From here, what we want to do is actually, like I said, kind of expand and explore the island. So maybe I'll make a method called explore island, and what we'll pass into it is the grid, again, this grid thing, and I and j depending on where we are. Clear some space there. And so what I'll do is make that utility function and call it, like I said, maybe explore island, self, it takes grid, I, and j. And so I'm kind of anal about these, but I like to clean it up there. So now we're going to say, I've stepped on a piece of land, let me explore this island now. First thing we want to do to say I have explored it, I'm marking my territory, is to actually change it. We'll change grid I of j to, like we said, a hashtag. I'm using a hashtag. You could use a percentage sign, you could use a dollar sign, you could do whatever the heck you want. Hashtag is kind of my go-to. Next, from here, we need to be able to say, let me check and explore any pieces of land above me, any pieces of land to my right, any piece of land to my left, any pieces of land below me, not to my left, and then any pieces of land to my left. So we'll do something like check above, check to the right, check below, check to the left. And we can do these in no particular order, it really doesn't matter. Since what we're going to be doing is modifying this in place, we're actually just going to be taking this grid array and modifying it as we go. We don't actually need to return anything from this utility function. So, well, in order to check above, we need a couple things to be true. One is we can't be at the top row. You know, if we're kind of here, we can't check above. And the other is we want to only kind of jump in and explore if there's a 1 above us. So our condition will be as follows. We'll say if I is greater than 0, and grid of I minus 1, j is equal to 1, then what we're going to, if it's equal to 1, then what we're going to want to do is we're going to recursively call this function on itself. So we'll call self.explore island, and we'll pass in the grid. We'll pass in I minus 1, which is our point above, and the j. And that's about it. We're now going to replicate this logic to the right, below, and to the left, or left, right? And that'll be it. And we're going to change it every single time we take a step into this function. First thing we're going to do is say, I've seen this piece of land, mark my territory, this is a hashtag. This is no longer going to be counted as a new piece of land because we're counting for new pieces of land right here. I'm sorry, I highlighted all of it. Right here, if we step on a 1 for the first time, kind of in our first piece of a potentially larger island, then we will add a result to 1. So these ones, we just want to set them as a hashtag while we're recursively traversing through this thing. Now we want to check to the right. So for this one, we want to say if j is less than, let me think, well, we want it to be the kind of the second last one because we can't check to the right if we're at the end. So if it's less than the length of the grid at I, minus 1, because again, we want to check just the second last one over, and grid I of j plus 1 is equal to 1. Then we want to do self.explore island, and same thing, grid I j plus 1. We're checking below. We want to say if I is less than the length of the grid minus 1, and the grid of I plus 1, which is again, I plus 1 of j is right below us. If that's equal to 1, we want to explore that. So self.explore island, passing the grid, so it can be modified. We're going to I plus 1, which is down below, and j, we're in the same column. Finally, we'll say if j is greater than 0, and the grid of I and j minus 1 to the left, if that's equal to 1, then recursively jump into there, explore whatever we got to explore, and then we'll come on right back after everything is marked with the hashtag. This actual grid will be modified in place. And so now what happens is, kind of as per our example here, if I rewind a bit, should I go back? After I mark all these with a hashtag, what's happening here is this. I'm now entering my old for loop, okay? I'm entering my old for loop after all this is done, and we're gonna kind of step through one item at a time. After I'm stepping through one item at a time, so we used to be here, this is our first 0, 0. Our next one in the for loop will be right here, right? But we're like, wait, okay, this isn't the one. Remember, our condition for counting a new island was if we're pointing at a 1. We are not pointing at a 1, we are now pointing at a hashtag, courtesy of the helper function that we wrote, explore island. Same thing, not a 1, not a 1, not a 1, okay? We get down here, not a 1, not a 1, yada yada, you get it. Eventually we get here, oh, here's a 1. We try to explore up, down, left, right, nothing there. So we mark it as a hashtag. I mark it as a hashtag. Our result is increased by 1. We go on with it. I think this explains it. Now, before I kind of get any cockier, let me try to submit this and make sure that it works. Okay, so no issues there. So this one, I know this is a bit of a longer video, but I really wanted to make it crystal clear as to how we can think about actually solving this. I noticed I kind of had this out a bit too wide here, so I do apologize if the scaling was a bit weird here on the code. As always, guys, any questions about this solution, drop them down below. Whatever you want me to solve next, drop it down below. Share this with your friends if they're struggling and y'all are studying together. Leave a like, subscribe, it goes a long way. And yeah, I'll see you guys in the next video. Peace.